Anytime we make a measurement, we can't be 100% sure about the actual value. And uncertainties is an attempt to describe how sure we actually are about a measurement. So what can cause these uncertainties in our value? Well, we have what are called random uncertainties, and that's the idea that something can just vary, not necessarily in your control, it could be out with your control. And these random variations, some of them might be a wee bit higher, some of them might be a wee bit lower. A good example might be temperature that's varying, that's affecting the reading you're taking. Reading uncertainties are to do with the limitations of the equipment that you're using. So how well can you read something from a digital scale? How much does that tell you about the actual value? And the same idea for what we call an analog scale, so something like a ruler, or like these traditional scales where you've got some sort of pointer on a scale. And then lastly, there's systematic uncertainties, which are due either to incorrect use of equipment or perhaps faulty equipment itself. And these, a good example of that would be if you didn't zero a set of scales before you used them. So all of the readings might be too high or they all might be too low in that case. So when we write an answer, we write it as value and then we use a symbol plus or minus the uncertainty. So for instance, if you've measured G, 9.7624, you can write that plus or minus the actual value. Now normally we would round the uncertainty off to one significant figure, except when that figure would be a 1, then you would often give a second significant figure. So in the example above, right, we wouldn't give all of those figures because the accuracy wouldn't warrant it. So we would use the final answer, the uncertainty to one significant figure would be 0.07. If you round that off to one significant figure. So there's where the 0.07 comes from, and then the value should be given to the same number of decimal places as that, i.e. 2 decimal places in this case. So that value will be rounded to 9.76. We can also express uncertainties as a percentage, and just like a standard way of working out any percentage, we do 0.07 divided by the value multiplied by 100%. So you could write the exact same information as 9.76 plus or minus 0.7%. The big advantage though of percentages is, as humans, we have a natural feel for how big a percentage is. You don't necessarily know that with the numbers. At 9.76 plus or minus 0.07, you might not know how significant that 0.07 is, whereas if it's a percentage, we have a much better feel.